Hi everyone, I'm Cheryl. In this problem, we're going to be estimating the limit as x approaches -2 of x plus 2 over the quantity x squared minus 4. And we're going to do it numerically. And once we've figured out what we believe the limit is going to be, we're going to see if that function actually ever equals that limit value. So we'll begin by filling in our tables. So all I'm going to do is I'm going to look at x as it gets closer and closer to -2. And if you notice in this table, I'm getting closer and closer to -2 from the left side. So all I want to do is plug these data points into x plus 2 over x squared minus 4. So when I take -2.1 plus 2 and divide that by -2.1 squared minus 4, I'm going to get a negative 0.2439. When I plug in negative 2.01, I'm going to get approximately a negative 0.2494. And when I plug in negative 2.001, I get approximately a negative 0.2499. Now, just looking at these values, negative 0.243, negative 2.49, negative 2.499, it looks like we're getting closer and closer to negative 0.25. However, when we do limits, we need to make sure that we come from both the left side and the right side. So I'm also going to look at some values getting closer and closer to -2 from the right side. So if I plug negative 1.999 into my function, I'm going to get a negative 0.2501. When I plug in negative 1.99, I get negative 0.2506. And when I plug in negative 1.9, I get a negative 0.2564. Now notice this time, my values are getting closer and closer to -2 when I go in this direction. So here I'm negative 0.256, negative 0.2506, and negative 0.2501. So it looks as I'm approaching from the right-hand side like I'm also approaching the number negative 0.25. So that's what I believe is my limit. Well, let's go ahead now and take a look at the function. So let's take a look at f of x equals x plus 2 all over x squared minus 4. I want to know if that ever actually equals negative 0.25. Well, I notice that I can factor the denominator, and I end up with x plus 2 all over the quantity x plus 2 times the quantity x minus 2, and that these will cancel. And so I'm left with 1 all over x minus 2, as long as x does not equal -2. Because at -2, this will have a function value. In fact, it'll be -1/4, and this will be undefined. Well, let's take a look at what this is graphically. 1 over x minus 2 is a rational function. It will have a vertical asymptote at 2. Let me draw in a vertical asymptote at 2. I also know that it's going to have a y-intercept when x is 0, so that means it will have a y-intercept at -1/2, so that's right about here. And it also has a horizontal asymptote at 0. So when I draw in my picture, it's going to look something like this. Now let's be careful when we get to -2, because at -2, that function is not defined, so we'll have a hole in the graph right here. All right, so as I can see, my function never actually equals the value at -2. And what's going to be, if I were to fill that circle in at -2, it would be negative 0.25. So the function never actually takes on that limit value. I hope that was helpful. Thanks.